Hello and welcome guys, this is Ashutosh, your host, and I welcome you all in this BEE class. So guys, today's topic is uh, we will learn from today first theorem of DC circuit, and that is called Thevenin's theorem. So guys, as you can see over here, we can directly go to the statement of Thevenin's theorem. So here you can see it provides a mathematical technique for replacing a given network. This is the given network. As you can see over here, it is already given. So this is the voltage source, DC voltage source, and the internal resistance of that source is given. Okay, it is already given small r, and then various resistances are connected in the circuit like R1 and R2. Okay, and between the 2 points A and B there is a load resistance connected, that is RL. So you can see clearly on your screen. So guys, this is the circuit. So it provides a mathematical technique for replacing a given network as viewed from two output, as you can see over here, two output terminals by a single voltage source with a series resistance. So the single voltage source will be VTH, okay, and the series resistance will be RTH. Both will be connected in series, and that will be the equivalent diagram of Thevenin's theorem. So it makes the solution of complicated networks, particularly electronic networks, quite quick and easy. And the application of these extremely useful theorems will be explained with the help of the following simple example. So guys, here you can see the example. This is the example of Thevenin's theorem जो आप यहाँ पर देख सकते हैं. This is the circuit, it is already given. So guys, first of all, two things we have to calculate: open circuit voltage, okay, this is called VTH, also Thevenin's voltage, okay, between these two terminals, okay, across which load resistance is connected, and the another is Thevenin's resistance RTH. Okay, so now we will move to our next slide. So this is the slide. Here you can see over here guys, this is the Thevenin's voltage VTH, and this is the Thevenin's resistance. Both are connected in series, and these are the two terminals A and B across which load resistance RL is connected. Okay, so and finally we have to calculate the load current by using this formula, because load current will flow through this circuit likewise in the clockwise direction I. Okay, because this voltage source will provide this current. So I can be written as VTH divided by RTH plus RL. So this will be the load current, okay, which is to be calculated in this equivalent from this equivalent diagram. And so you can see over here Thevenin's resistance, it is also sometimes written as Ri or Ro, okay, and consequently as viewed from terminals A and B, the whole network is excluding R1 can be reduced to a single source called Thevenin's source. So guys, now we can directly move to the next slide and see what are the different steps of Thevenizing a given circuit. So guys, here you can see these are the different steps of Thevenizing a given circuit. So this is the first step. What we do, temporarily remove the resistance called load resistance RL, whose current is required. So first of all guys, सबसे पहले आपको लोड रेजिस्टेंस को रिमूव करना पड़ेगा, which is connected across 2 points, whether it could be XY, AB. Okay, so it is also called load resistance. Okay, then second step, find the open circuit voltage VOC or VTH, which appears across the two terminals from where resistance has been removed, and it is also called Thevenin's voltage. So guys, second step में आपको VTH या VOC फाइंड करना है, और जिसको ओपन सर्किट टर्मिनल वोल्टेज भी कहा जाता है. It is also called open circuit voltage. Okay. And third step compute the resistance of the whose network has looked into from these two terminals after all voltage sources have been removed. Okay, and called Thevenin's resistance. Now guys, आपको RTH find करना है, Thevenin's resistance. So यहाँ पर इसके लिए in order to find RTH you have to replace the voltage source by its internal resistance or current source by its internal resistance. So guys, अगर अगर guys voltage source है, if there is a DC voltage source, so the ideal resistance, internal resistance is 0. Okay, so a battery must be replaced by a short circuit, by placing a short circuit. So because the internal resistance of a ideal voltage source is always equal to 0, so we always replace a battery by its internal resistance by a short circuit. And if the source is or current source, so the current, so ideal current source has internal resistance is equal to infinite. So guys, we will replace that current source by open circuiting the terminal. So these must be remembered. Okay, so guys, next step you can see over here, connect RL back its terminal from where. Okay, and now find the load current. Okay, these are the steps. Now we will take directly a problem, okay, a numerical, and then we will solve that numerical in stepwise. Okay, and see in the next slide, this is the problem guys. Here you can see over here, this is the Thevenin's theorem. Okay, as you can see over here, 110 volt DC voltage is connected, as you can see over here, then 100 ohm resistance, and between this 300 ohm resistance is connected, and there is 200 ohm resistance, and there are two points, two terminals. Between these two terminals A and B, load resistance is connected. Okay, you can see over here, this is the load resistance RL, and the value of load resistance is 500, as you can see over here. So guys, first of all, the first step of solving the Thevenin's theorem is, first of all, remove this load resistance. इस load resistance को आप remove कीजिए जो connected है A और B terminals के बीच में. Okay, this load resistance is connected across, okay, two terminals A and B. So remove this. Now these terminals will get open circuited, as you can see over here, and so the voltage across these terminals is to be calculated, and that voltage is to be called VOC or VTH. इसी को आप ओपन सर्किट वोल्टेज कहेंगे और इसी को आप VTH भी कहेंगे. So both are same. So guys, so next step is to find current. Okay, so now the circuit becomes like this. Okay, when you already remove the load resistance, okay, and place VTH like this right here, okay, and make mark arrowhead, okay, and this will be VTH, and then this circuit is open circuited. Okay, now no current will flow in this circuit, but there will be a current will flow in this circuit. This is a closed loop, okay, or mesh. So here current will be there. So now calculate the current. You can apply KVL or reduction method. Okay, so you can directly write I equal to 110 volt divided by 100 plus 300. This is the 100 plus 300, both will be in series. So the current will be equal to 0.275 ampere. So you already calculated the current. This is not the load current. So guys, always remember, this is only the current in the mesh. Okay, not the load current. Load current will be calculated at last. Okay, once we get the equivalent circuit. Now the step number 3, as you can see over here, step number 3, find VTH across A and B और VOC ओपन सर्किट टर्मिनल वोल्टेज। तो गाइस एक बार अगर आपने करंट कैलकुलेट कर लिया तो इसके बाद का जो स्टेप है वो है आपको ओपन सर्किट टर्मिनल वोल्टेज फाइंड करना है या VTH फाइंड करना है। जैसा कि आप देख सकते हैं, एज यू कैन सी इन द नेक्स्ट स्लाइड, okay, current, the value of current you already calculated 0.275 ampere. Okay, now ये करंट कहाँ फ्लो हो रही है? ओके, सी द डायरेक्शन। ओके, सो put the positive symbol before this resistance because the current is entering at here of this resistance, and of this resistance the current is entering at here, so put a positive symbol and then a negative symbol because from here current is leaving. तो आपको अब voltage drop लेना है, you have to consider the voltage drops across the resistance. Okay, so guys, generally ए से लेकर बी तक का वोल्टेज कैलकुलेट किया जाएगा। ओके, यू हैव टू कैलकुलेट VTH across these two terminals. So you have to follow this path. Okay, this is the shortest path. Okay, you are traveling from, like, this is like you are traveling from A to B. Okay, and so during this travel you have to account all the voltage drops. ओके, सो अप्लाई ए KVL, यहाँ पर आपको KVL अप्लाई करना पड़ेगा। ओके, क्योंकि ये शॉर्टेस्ट रूट है ए से बी तक का, और इसीलिए गाइस आपको पॉजिटिव और नेगेटिव टर्मिनल पता होना चाहिए, और उस रेजिस्टेंस में, पर्टिकुलर रेजिस्टेंस में, ओके, यू शुड नो द वैल्यू ऑफ वोल्टेज ड्रॉप। ओके, सो लेट्स find the VTH. Now you can write down, okay, you can write down like this, VOC is equal to VTH and that is equal to, अब यहाँ से आप ट्रेवल कीजिए। ओके, ओके, we will start from A point. Okay, now come at 200 ohm resistance, whether there is any voltage drop or not, so current is 0, voltage drop is 0. Okay, so no need to write 0, yeah, or you can write down 200 resistance into 0 ampere current, so it becomes 0. Okay, and then, okay, come here at this resistance. Okay, you are also entering, you already at positive point, so the voltage drop, what will be the voltage drop across this resistance? Plus 300I. Okay, always remember the voltage drop, because you are entering at positive terminal of the resistance, so it will be plus, then 300, voltage drop will be 300 into I means 0.275, you already calculated. Okay, and so you can write down VOC or VTH equal to, this becomes 0, so no need to write this. Okay, because this is already 0, so the product of 300 into 0.275 becomes 82.5 volt. So this will be your answer number 1. This is called Thevenin's voltage or open circuit terminal voltage, okay, across these two terminals, 82.5 volt. Okay, so let's move to the next slide. And now the next step, step number 4, okay, or whatever you call it, okay, find equivalent resistance between these 2 points A and B. Okay, that will be called RTH. So guys, what you have to do, remove RL. This is the first step of finding Thevenin's resistance. First of all, remove whatever the resistance connected between these two terminals, that will be called load resistance. So remove RL from this terminal, okay, like this, and then short circuit battery, okay, or voltage source, because the ideal battery's internal resistance is considered 0 ohm, so we are placing a short circuit here. As you can see here, we are placing a short circuit. Now this circuit is closed. Okay, now you have to reduce the resistance from here. Okay, start a reduction of resistance from here. You have to view from here, this side. Keep an eye. Okay, keep an eye from this terminal, and you have to reduce the resistance values from here. at this terminal. Okay, so first of all, these 100 and 300 ohms will be in parallel, as you can see over here. So you can write, and the combination of these parallel resistances will be added in series resistance 200. Okay, so the total RTH will become 275 ohm, 275. Okay, so this will be the value of RTH. Okay, so we will move. Now guys, we have to draw the equivalent diagram. Okay, now finally step number 5, draw the equivalent diagram. Okay, place VTH like here, then connect RTH in series with the VTH. Okay, like it is already drawn in the circuit, and then place connect load resistance again across these two terminals A and B. Okay, and now finally the final step is find load current flowing through this load resistance in this circuit. Okay, so it becomes apply KVL. So also you can write 82.5 divided by 275 plus 500. So it becomes IL equal to 0.10645 एम्पियर. So guys, ये आपका लोड करंट होगा, और इक्विवेलेंट डायग्राम फाइंड करने के बाद आपका ये लास्ट प्रोसीजर है कि आप लोड करंट फाइंड करते हैं. सो दिस इज द लोड करंट. सो गाइस, ये आपका थेवेनिन्स थ्योरम था. दिस वाज ऑल अबाउट थेवेनिन्स थ्योरम्स. ओके, सो नाउ in the later class we will discuss, okay, we will discuss the some numericals. Okay, एग्जाम्पल है थेवेनिन्स थ्योरम का. यहाँ पर आप देख सकते हैं, दिस इज द प्रॉब्लम ऑलरेडी गिवन. ओके, you can see on the screen. So here 15 voltage battery is there, and there is 12 volt battery is there, but opposite, connected in opposite direction, and there are 3 ohm resistance, 6 ohm resistance, and 3 ohm resistance, and these are the two terminals A and B, and no load resistance is connected. So guys, what you can do, so first of all, if there is no load resistance is given, अगर आपको लोड रेजिस्टेंस नहीं दिया हुआ है, तो आप डायरेक्टली सेकंड स्टेप पर आ सकते हैं, और वो है गाइस, यू कैन डायरेक्टली स्विच टू द सेकंड स्टेप, एंड विच इज फाइंडिंग ऑफ करंट. ओके, फाइंडिंग आउट ऑफ द करंट. So you can directly find out the current. So current will flow in this loop. Okay, 15 volt voltage source is greater than 12 volt. Okay, so if there are two voltage source, then you must see the which one is greater voltage. Okay, so 15 voltage source is greater, so current will be in clockwise direction. Okay, and also this voltage source is also added, because the direction of current, in the same direction of current it will flow. So what will be the current? So you can write down I equal to, you can also apply KVL, and if you apply KVL, so minus 15, it becomes the equation minus 15 plus 3I plus 6I minus 12 equal to 0. Okay, so you can write it down, as you can see over here, it is written over here, and then I can be calculated 15 plus 12 divided by 3 plus 6, so it the value of current is 3 ampere. And now you have to, this is plus terminal, A is always at plus terminal, and B is always at negative terminal. Now you have to find out the VTH. So guys, we have to travel from A to B in this shortest path. Okay, so what you have to do, find out the voltage drop, place a plus symbol here, over here, and minus over here, because current is entering into this resistance, okay, from top to bottom. So the voltage drop is equal to 6 into 3, 18 volt. Okay, now take VTH equal to, write down VTH equal to, okay, so see the first resistance, there is no current in this resistance, so the voltage drop becomes 0. Now see the voltage drop in 6, so 6 3 ja 18 volt, plus 18 volt will be written as plus 18, and then you enter at minus negative terminal of battery, so you can write minus 12, and therefore the VTH is equal to 6 volt. Okay, so the answer will be 6 volt. Now you have to find out the RTH. So guys, in order to find out the RTH, you have to place these batteries, okay, with their internal resistances. So short circuit, place a short circuit over here, also place a short circuit over here, and then reduce these resistances from here. Start reduction, reducing from here. Then 3 and 6 will be in parallel, it becomes 2, and will be in series with 3, so it becomes 5 ohm. Okay, so guys, now you already learned the procedure of solving Thevenin's theorem. Now you can solve it by yourself. So guys, we will meet in our new video tutorial session. Till then, goodbye guys. Okay, then we will go to our simulation where we can directly connect voltmeter, ammeter and resistance for measurement of resistance multimeters. Basically all the three circuit diagram you can see over here. This is also multimeter, but this is working like ammeter. Okay, we have selected ammeter. This is the ammeter. This multimeter is working as ammeter. Then in the second diagram, this multimeter is working as resistance meter, ohm meter. Then in the third diagram, this multimeter is connected like a voltmeter. Okay, so we will come in this. So first we will solve the numerical and we will see what are the values that comes. Okay, what are the different values. So step number 1, I will tell you the step how to Thevenize the circuit. So first we have 110 voltage source, 100 ohm resistance, 200, 300 and 500 load resistance. So first step what you are doing, first step you have to do remove load resistance temporarily remove load resistance from this given circuit. Okay, so in the second circuit here drawn here over here you can see RL is removed. This is RL 500 ohm, and now AB, these terminals gets open circuited, and now you have to find out the current. In the second step, see here, in the second step find the current in the closed loop. Now this circuit gets open circuited, so no current will flow here through here, and current will flow through this closed circuit. So now find out the current. I is equal to 110, this is the voltage, 110 divided by 100 plus 300, so it becomes 0.275 ampere current. You can see over here, this is our second step. Then in our step number third, find out VTH across A and B, across these output terminals, which will also be called open circuited terminal voltage, VOC. Okay, VOC. Now we have already found out the current, and the value of current is 0.275 ampere. So just put here positive sign across this resistance and put here negative sign. Where current enters, that will be positive. Okay, so we have put here positive sign. It will be called positive, it will be called negative of this resistance, because current is entering at this terminal, so it will be called positive, and leaving from this terminal it will be called negative terminal. So calculate voltage drop across this resistance, and we have to calculate the VTH, open circuit terminal voltage, across A and B. So we have to travel A to B. Okay, this is our A and this is point B. So we have to calculate the voltage across A and B, and we have calculated the voltage across A and B. So let's start from this point. Okay, move from A towards B. Okay, this is the short path from A to B. So we have to calculate and sum all the voltages across it, all the voltage drops. Okay, so calculate C in 200 ohm. First resistance will be 200 ohm. Okay, from leaving A terminal, 200 ohm will be there, and there is no current in 200 ohm, so the voltage drop becomes 0. Okay, to VTH equal to, you can write VTH equal to 200 into 0 current. No current is there in this resistance. Then again move from here and then we will enter in this resistance. So take voltage drop of this resistance and that will be equal to plus. You have to write plus because we are entering here at this terminal, that is positive. So positive, we have taken this positive 300 into I. Okay, this is the resistance I into R. I into R, 300 into I, and what is I? I is 0.275 ampere. So multiply this, so it becomes VTH equal to open circuit terminal voltage equal to 82.5 volt we get. This is our answer. Okay, so this is the Thevenin's voltage. Now, okay, move further. Step next, find out RTH. So guys, in previous circuit, replace the voltage source by a short circuit. Okay, find out RTH. For that, remove load resistance. We have removed the load resistance already here. Okay, you can see here. Then what is other step? Okay, and short circuit battery or voltage source means replace this voltage source by its internal resistance, because this is ideal voltage source. So we have replaced this voltage source by short circuit. Now calculate R equivalent across these 2 points A, B. These are fixed. Okay, so you have to start from this point. Okay, so start reducing these resistance. So 100 into 300, how these are connected? 100 and 300 are connected in parallel. So you can write the RTH will be, the value of RTH will be equal to 100 into 300 divided by 100 plus 300, both are in parallel, plus 200 ohm is in series with the combination of these. Okay, so plus 200, and finally RTH we get 275 ohm. And then next last step is Thevenin's equivalent diagram. Draw the Thevenin's equivalent diagram. So you can write VTH, place the value 82.5, RTH 275, and reconnect RL, that is 500 ohm, and calculate load current IL equal to VTH upon RL plus RTH. So 82.5 divided by 275 plus 500, it becomes 0.10645 ampere. Okay, so this is the load current. Now we have to verify whether in that simulation circuit where we have drawn the simulation circuit, same circuit we have drawn over here. Okay, now we have to verify by connecting multimeters. Okay, that will work like voltmeter, ammeter and ohm meter. So first you can see here we are putting this PPT. Okay, here. Okay, so okay, now first I am minimizing this. Okay, so we have drawn this circuit and we have connected, this is our load current measurement. Okay, we have connected the multimeter that is working like ammeter in series with the load resistance. Here you can see it is connected in series. And what is the value when you start the simulation? When you start the simulation by running this, okay, so you will get 106.452 milliampere, and that is same load current, that is the same load current. You will see load current IL. This is the load current IL, 0.10645 ampere, and both are same. Okay, whether you write 106.452 milliampere or you write IL equal to 0.10645 ampere. So theoretically and practically the readings of load current are same. Okay, we have solved manually. Okay, so we get IL equal to this, and now we have connected ammeter in series with the load, and it is telling us 106.452 milliampere. Okay, now see next. Okay, this is our circuit 1. When load current IL is measured across load resistance of 500 ohm, the value of load current is this. So this is verified. Okay, this is correct. Now we will move further to our next circuit. Circuit is same, but now what happens? We have to find out RTH. Okay, and this, for this, what is happening here? We have replaced our voltage source with a short circuit and connect and remove load resistance and connect a multimeter which is working as a ohm meter, and what it says, it is giving 275 ohm. You can see here 275 ohm. This is our RTH, and you can also see in our presentation the value of RTH is 275 ohm. 275 ohm. Okay, so both are verified, both are correct. It is also giving us reading 275 ohm, so it is also correct. So RTH is also verified. Now we will move further to our third circuit. Here we have calculated VTH. What is the value of VTH? So battery will be there, resistance will be there. What is to be done? Only RL is to be removed. Only load resistance is to be removed. So we have connected multimeter again across these two terminals, these 2 points across A and B. Okay, and this is working like voltmeter. So what it tells, it is giving us reading 82.5 volt. When you run the simulation, okay, when you stop, you can stop by clicking on this red button. Okay, and you can run the simulation by clicking on the green button. So it is giving the VTH 82.5, and you can see in the PowerPoint presentation what we have calculated. VTH is 82.5. We have solved this numerical and we already found VTH equal to 82.5 volt, and by practical you are getting 82.5 volt. So this theorem is verified. You can say this is our Thevenin's theorem verification in the multisim software. So guys, that's it for today, and you can download the software from internet and easily draw the circuit and simulate any circuit, whether it is KVL, KCL or any other theorems. So that's it for today guys. We will meet in our next video.